Okay, back again. You're probably thinking, good God, him again, bring the gorilla. But no, it is me. And I thought I'd do an application of vectors, something that you might be asked to do in the exam. It bobs up. It's not worth a lot of marks, but it's definitely something you need to be able to do. And that is vector proof using vectors. Now, I've chosen an example from the textbook. It's on the PDF file that you guys already have opened because you've opened it from the previous little clips we've had. So I'm going to do exercise 2E, question 9. Okay, so exercise 2E, question 9. Now, it's asked us to basically show that if we've got a quadrilateral and we have the midpoints of the sides of that quadrilateral, when you join the midpoints together, you get a parallelogram. Amazing, isn't it? Fantastic. Pages and pages proving that, but vectors, it's really, really simple to prove it. All right? So let's draw some crummy old quadrilateral. There it is. Not crummy enough. I think it's not a quadrilateral, it's a triangle. There we go. That looks pretty crummy. Now, the reason I want it crummy is I don't want anything in it to look special, because if there's anything in it that looks special, that's probably going to suck me in at some stage and I will assume something I'm not allowed to assume. Like if I had drawn this and it looked like I had a 90-degree angle somewhere, I might get sucked in down the track into saying, oh, of course this angle's 90 degrees, and it's not, of course. There is nothing in this quadrilateral unless the question tells you it. All right, so it is just a crummy four-sided figure. Nothing special about the angles, nothing special about the side lengths, okay? Now, I'm going to label the corners. This is going to be a bit awkward because this looks nothing like the thing I have written on my sheet here. So, let's throw that away now and we'll just go blind here. Fly solo, no safety net. A, B, C, D. Now, we'll get the midpoints. Now, there's a midpoint, there's a midpoint, there's a midpoint, where's a midpoint? We'll call it M, N, P, and Q, just to be contrary, no O, okay? Now, if we join those midpoints up, look at that, it does look like a parallelogram, doesn't it? That's good, because that's what we've got to prove. And it's not good enough to say, yeah, it looks like a parallelogram, my God, I've done it. No, we've got to prove it using vectors, all right? Now, what I do want to do before we start that is I want to try and write down the information that we know about this thing, all right? We've been told that these are midpoints. Now, what that means is that the vector AM, therefore, is equal to the vector MD, and they are in fact both the same as half of the vector AD. Okay? Now I know that because this is the midpoint, so that length is the same as that length. AM is in the same direction as MD, so therefore they've got the same length, the same direction, they're equal to each other. Okay? And because it's halfway, AD is also in the direction, it's half of the vector AD. Now in a similar way, we can say that the vector DN is equal to the vector NC is equal to half of the vector DC. We can say that the vector CP is equal to the vector PB, and that is equal to half of the vector CB. And we can finally say that the vector AQ is equal to the vector QB is equal to half of the vector AB. That's been given to us, right? It's been given to us by the fact that we were told these were the midpoints, all right? Now, it's helpful to have the information there because it can often help you see how you might get started. It can often help you sort of work out how you need to continue. If you get a bit stuck, you go back and look at what you know. Now, I'm going to try and make life a bit easier for myself as well by naming the vector AD because, I mean, this pen's going to run out of ink because the department's so cheap. So I don't want to save on ink. So instead of ADs and all the time, I'm going to let the vector AD, I'm going to call that the vector A. I'm going to call the vector DC, I'm going to call that the vector B. The vector CB, I'm going to call it the vector C. And the vector BA, I'm going to call that the vector D. Now, the reason I've done that, in fact, is so that I can actually say that A plus B plus C is actually going to equal the vector D, and that's going to be a little helpful thing. Obviously there's a relationship between 3 of these vectors and the 4th one, and that's a nice simple relationship. So I know that A plus B plus C is equal to the vector D. Excellent. Now, they reckon this thing's a parallelogram. It certainly looks like that, but we've got to prove it. Now, we know what a that gorilla's putting me off that. A parallelogram. We know what a parallelogram looks like. It's a 4-sided shape. The opposite sides are parallel. Now, I'm going to prove that these 2 sides are parallel. Okay? The proof for these 2 sides is going to be exactly the same, and you guys can do it yourself. All right? So I'm going to try and prove that these 2 sides are parallel. Now, how I'm going to do that is I'm going to try and prove that the vector Mn is equal to the vector Qp. Now, if I can prove that, then I've shown that these 2 sides are parallel and in fact have the same length as well. Okay? So, I need an expression for the vector Mn first of all. Now, the vector Mn, what's it going to be? Well, the vector Mn is going to be the vector Md plus the vector Dn. Handy little tip, by the way. I know that without even trying to figure all this out, because the head of that guy is the same as the tail of that guy. Rub them out, you've got your M and your N back. Okay? So there's the tail of your vector, there's the head of your vector. Okay? Works for any pronumerals. If those 2 symbols are the same, then your tail and your head of the vector. Okay. Now I know that my vector MD, he was here somewhere, there he is half of AD, and I know that my vector DN, there is half of the vector DC, and I know that my vector AD is the vector A, and I know that my vector DC is the vector B. So if you think about it, that's actually going to be the same as half of A plus B. Now in an exam, you probably wouldn't be asked to do this cold. In fact, there would probably be a part A, which would be find an expression for the vector Mn. And you do that, and then that lead you through the proof. All right. Now the vector QP. Now what I'm really hoping, just realised a really good look on my face, and but I wasn't looking at the camera. What I'm really hoping is that this vector QP, the expression I get for it, is going to boil down to be the same as this, because then they're equal to the same thing, so they've got to be equal to each other. Remember that little handy trick I mentioned earlier. So, the vector QP, now let's see. Where are we? There's the vector QP. It's going to be the vector QB plus the vector BP. Now again, I didn't really need to refer to my diagram for that, because notice they cancel the tail and the head of my QP. Now my QB is going to be a half of the vector AB. I'm going to do this a bit more carefully, just so you can see that there's no tricks, nothing up my sleeve, okay, except perspiration in case I make a mistake and sweating here. We got half of the vector A plus, now my BP, now we've got to be careful here. My BP is going that way.
Excuse me, sir, isn't it the vector D?
What happened to the gorilla? Oh, my mistake, it was a gorilla, I pointed that out. My mistake. Thank you, Mr. Campbell, it is the vector D. Believe it or not, there's actually teachers have to suffering through this at the moment, just in case I screw up, and I'm going to point it out, because the gorilla had to take a break, and something to do with sort of cruelty to animals if they don't take a break. Anyway, so we've got the vector half, that's half D. Excellent. Now, the vector BP, we've got to be careful here, because it's not half of C, because my vector's going the wrong way. So it's actually going to be half of negative C. So it will be plus half of the negative C. All right? So that's a half outside of D minus C. Now, 1/2 outside of... Now, my vector D, I wrote it up here. It's A plus B plus C.
Isn't it negative D, Mr. Kerman?
A.
Isn't it negative half D?
You're just full of helpful advice today, aren't you, Mr. Campbell? I'm going to kill him. Where were we? D. What did I want? I wanted the vector QB. The vector QB, it is negative D, you're right. Didn't I hate it? Alright, so D, and that is a minus C, isn't it? Yeah?
Yes.
Alright, thank God for that. Okay, so we want the negative of the vector D. It's going to be the negative of all of this. So it's going to be a negative A, minus a B, minus a C. You know, he's just made me screw up, you know, because this is not going to work out now because of his butting in. So the gorilla's taken a break, gone to get another banana or something. Can we stop for a moment? Okay, I've sorted that out now, and I've had a little chat with Mr. Campbell as well. In fact, that A plus B plus C, it's not equal to D, and I know a few of you are probably dying to tell me that, but I'm not really there. So you couldn't tell me, you're wriggling around in your seats. That's actually equal to negative D. There's a negative D there, alright? Because A plus B plus C, there's the head and there's the tail. So, and it's going in the wrong way. So, although my D is going that way, that vector A plus B plus C is actually negative D. Okay? Because the tail of A is there, the head of C is there, and so the resulting vector looks like that, but my vector D is going that way. So the resulting vector is the negative of vector D. Okay? It's a bit unfortunate. It looked better on my little crib sheet I had. So working through all this, so that's all good. We're happy with that. Now my QB was equal to the negative of D. So we've got half a negative D, half a negative C. Now, so my negative D. Is that going to work?
Beautifully.
A plus B plus C.
Oh, look, you know what? And now, ladies and gentlemen, a special cameo appearance by Mr. Campbell! Drum roll, please. We've got no drums.
Okay, so all you substituting is you know that negative D is A plus B plus C. Write that in. These cancel out, the C's cancel out, and you're left with half A plus B, which is what you wanted.
Thank you, Mr. Campbell. He's my protege, you know. I'm trying to give him the experience. He'd like to teach specialist maths one day. Give him the experience. Okay, so we see that our vector Mn is half of A plus B. Our vector Qp is half of A plus B. So therefore, the vector Mn is indeed the same as the vector Qp. Therefore, sides Mn and Qp are parallel. Now, in a similar way, minus the mistakes, you'll show that the side MQ is parallel to the side NP in a similar way, and that would complete the proof that you've got a parallelogram there, and that would actually complete the lesson.